In this video, you will learn how to manage your cloud and hybrid environments like a pro with event-based automation. My name is Eamon O'Reilly, and I'm Principal Program Manager on the Azure Functions team. It is important to be able to manage across both your applications and infrastructure. This applies to how your resources are deployed, secured, protected, monitored, configured, and governed. As these steps are applied to your environment, you need to be able to automate these tasks so that they can be easily managed and reproduced at scale. In this video, we're going to focus on how to develop event-based automation in your organization so that as resources are deployed or removed, you can apply your automation. For example, as a VM is removed from your infrastructure, you would write automation that updates the monitoring system that is watching for alerts on this machine. Also, you'll want to be able to operate your environment with automation so that as changes happen, you can easily apply automation. The 5 key patterns we will discuss today will enable you to develop a set of automation that can manage both your cloud and on-premises resources in a consistent way with Azure Functions. These patterns consist of how to respond to events on resources, how to build scheduled tasks, process Azure Alert events, how do you expose your automation, so build in business logic so you can expose this as a webhook or an API. And then the last pattern is how to integrate and orchestrate with external systems you may already have inside your environment. We will first focus on one of the most common automation tasks, which is running scripts on a schedule. So in Azure Functions, this is accomplished by using the timer function and using the cron tab expression. This also supports daylight savings time by using the website time zone app setting. Some common scenarios for scheduled tasks are stopping VMs at night and starting them up in the morning, performing SQL maintenance tasks, and also removing resources that are no longer needed, maybe based on a tag. So let's switch over to the Azure portal and go through the first demo that shows how to start and stop VMs on a schedule. You can see here I'm in an Azure function. I'll click into the functions I created to start and stop my VMs on a schedule. If I go into the code and test for the start VM on timer, you can see how to write the PowerShell and how easy it is to get up and running. In this script, I'm looking for all VMs that have a tag of cost set. And then what I do is I look for what time for the start and stop is set inside of that tag. And if it matches when this script is running, then I'll go ahead and start the machine. And similarly, in my stop VM script, I'll do the same. If it's the time matches when it's supposed to be stopped, it will stop. And if I go into integration, you'll see that this is triggered on a timer function and that it's running every hour. So every hour this function runs, it looks for virtual machines that need to be started, and then the other function looks for ones that need to be stopped. But another nice capability of Azure Functions is the ability to create an identity for the Azure function so that it can automatically manage your Azure resources. So here you can see I have a system assigned identity created, and I've granted access to this identity to my subscription. And so this allows this function app to go and manage all of the resources inside of this subscription. And if I go and look at the app files, you'll see there's a profile.ps1 PowerShell script that gets run each time the function app starts. And one of the things it does, it actually checks if the identity is enabled on this function app. And if it is, it connects with this identity so that all the scripts I write can use this identity to go and manage the resources. So you can see here, it's really easy to get started writing a PowerShell function and hooking it up with a timer trigger. The next pattern we're going to look at is how to respond to events on resources inside your Azure environment. When resources change in your Azure environment, there is an event grid service that captures these changes and has the ability to call an Azure function to process the change. This can be very useful when you want to trigger a set of automation based on resource changes without having to poll the Azure service looking for them. Some examples of this are adding a tag with some looked up values when a resource is created. Perhaps you need to grant access to your operations or your dev teams on a resource group. Or when someone deletes a resource, you might want to get notified of this in Teams. So there's a whole set of automation that you want to hook up when resources get created or modified or deleted, and that's very easy to do inside of the Azure service. So let's go back into the portal and see how you can integrate Event Grid with Azure Functions to perform actions on these resources. So if we go back to our function app, you'll notice there was an additional function in here called Add Tag to VMs, and you can see that it is of type Event Grid. And so if I go into this function and look at the PowerShell code, you'll notice that it's adding that cost tag I was looking for earlier, and it's adding the value of start time of 7 a.m. and stop time of 7 p.m. And so what this allows you to do is every time a new VM gets created inside of the Azure environment, this will run and it will actually add this tag to the virtual machine. And this allows the owner of the virtual machines to then go modify this and say, no, I don't want this to be started and shut down, or I do, but I want it at different times than the ones that are specified here. So it still gives the management capability to the owner of the VM, but it will automatically add them so that they're set up for this automatic start and stop across the subscription. But the one thing to call out here is that the information about the VM is actually passed in by the Event Grid service. And so let's go look and see how the Event Grid actually calls this function app and passes in the information about the machine. So if I go to Event Grid subscriptions and I filter on Azure subscriptions, you can see that there's an event subscription called Add Tag to VMs, and it's calling that function Add Tag to VMs that I just looked at. So how this is configured is you can see that it's looking for all operations across the subscription that have a resource write success. So someone has written a new resource and the operation contains Microsoft.compute/virtual machine/write. And so this is looking for specifically every virtual machine write that happens inside the subscription. And when that occurs, I want to go and automatically pass this information about the machine to my Azure function so I can go and add the tag. And so this kind of shows how you can hook up Event Grid very easily with your Azure functions and have the ability to perform automation as events happen across all the different types of resources you have inside your Azure environment. The next pattern we'll look at is how to react to alerts triggered by Azure Monitor. Azure Monitor has the ability to trigger alerts when certain monitoring conditions are met on your applications or resources within Azure. There is a native integration with Azure Functions so that remediation could be automatically applied when the alert fires. Examples of this might be send a Teams event when Azure Functions are failing, perhaps restart a service inside a virtual machine if it stopped, or maybe truncate a table when SQL database reaches its maximum size. And so everything that can be captured inside of Azure Monitor has the ability to trigger an Azure function in order to perform remediation. And so let's go back to the portal and see how this is configured. So the first thing I want to do is go to Azure Monitor and then go to Alerts so that we can create a new action group. So here you can see I have trigger function to start service action group. And if I click into that, you can see I've created an action which is to call an Azure function. And if I look at that, you can see it's calling my function restart hybrid service inside of my function app. And so with this, you can create as many of these action groups as necessary and call Azure functions to perform some remediation. And so now that you have an action group created, you can now tie this action group up to an alert inside of Azure Monitor. So if I go to an alert rule and create a new alert rule like I have here, you can see I've set up a custom log search that's looking that will get fired when a certain event occurs. So if you come down here, you can see it's basically looking for Windows services inside my virtual machines that has stopped, and the service name is print spooler. So anytime that this happens across any of my virtual machines that I'm monitoring, I want to send an alert. So when the threshold is greater than 0, then the alert should fire. And so what will happen once that alert fires is you'll want to actually take an action on this. And so this is where you could select that action group I created, so trigger function to start service, and it would go ahead and call my Azure function and pass in information about the alert so that I could go and perform some remediation against that alert that just fired. And so here you can see how easy it is to hook up your monitoring capabilities inside of Azure with your remediation capabilities with Azure functions by creating an action group with your Azure function and then triggering this from the alert when it fires. The next pattern we're going to look at is how to expose some business logic you need for automation as a webhook or an API so that it can be integrated in with external systems you might have in your environment or called as a standalone API. So Azure Functions has a native capability to expose itself as a HTTP trigger or webhook. And so this allows you to author all of your business logic in there and then to expose it as an endpoint either directly as an Azure function or to integrate it with Azure API management so that you get a full API capabilities on top of the business logic. And some of the common scenarios you might want to do with this is to trigger on-demand automation like collecting logs for a failing service, or maybe onboard a user to an organization. And so maybe you have to set up their resources like their mailbox, grant access, and maybe integrate it with external systems like Logic Apps. So anything that requires a set of business logic that you want to expose as an API so that can be triggered for a set of automation tasks, then that's another pattern to look at and to see the capabilities Azure Function has. So with that, let's go and see how we could create an API on top of an Azure function that restarts our OS service. So if I go into my hybrid function app and look at my functions, you can see that I have a new function called Restart Service API, and it's a HTTP trigger. And if I go look at the PowerShell code for this, you can see it's taking in the input from the request body, and it's looking for a couple of values inside of there, the service name and the computer name. And then it's printing those out. And so it has the ability to take that information and go ahead and do anything it needs to with that computer name and service name. For this scenario, I'm just writing them out to kind of show how easy it is to hook up an API to this endpoint. So once you've got your function written, you can now expose this as an API, either exposing it directly by calling the webhook, so I can just get my function URL here. But ideally, you'd want to put API management in front of this to give you all the capabilities of API management, but then the ability to run the code using PowerShell in functions. So I go to API management. You can see here that I'm calling my function app. And so I'm going to call that function, but I'm exposing my operations like get and post on top of that API. So perhaps I want to call, restart the service API, and I can go and test this. So if you remember, I can add a couple of parameters like service name, and call that spooler. And I'll add another one for computer name. And make that finance one. So I've added a couple of parameters, and then I can go and send this. So you see, it said OK. And I got a response with the computer finance one and service of spooler. So when I go back inside of here, you can see it was called and it got the computer name and spooler, and it returned it back. So just with by doing a couple of steps inside of the function app and then hooking this up with an API management, you now have the ability to expose this API and call it externally from another application or directly from the command line. So any kind of business logic you want to wrap inside of a function app can now be done and then exposed out for any other third-party system. Okay, with that, I'll go back to the last pattern that we see most of our customers doing. The last pattern we're going to look at is how you can integrate and orchestrate with external systems. And in order to perform this with Azure Functions, we're going to integrate with another Azure service, which is Logic Apps. And the nice thing about Logic Apps is it has the ability to orchestrate processes across various systems to perform your end-to-end automation. So it has a lot of built-in connectors, over 300, as well. It's very easy to kind of author your business logic and have long-running processes. And then you can call the Azure functions to do specific work when those processes move to their next step. And so some of the common scenarios you'll see with Logic Apps is the ability to perhaps do an approval in ServiceNow by integrating Logic Apps with ServiceNow. And then when that happens, go call an Azure function to fulfill the request. Or send customized email notifications when an automation task is completed. So there's a whole set of scenarios that you can implement inside of Logic Apps when you need a kind of an end-to-end orchestrated workflow. So let's go back to the portal and see how we can leverage some of those other capabilities we built in the previous demos to kind of do an end-to-end workflow where we approve restarting of one of our services inside our virtual machine. So if I go back into Azure Monitor, you can see that I have an alert that's fired. And I'll go in here. And you can see that it's calling the restart spooler service is stopped. So you can see this fired earlier. And it's going to call this alert rule restart spooler service is stopped. So I'm going to go in here. And if you remember, this was that one I set up earlier where I could have called an Azure function, but instead, in this scenario, I'm going to call an Azure Logic App when this fires. And so the service has been stopped, and my Logic App is going to get triggered by Azure Monitor. And so if you go into a Logic App that I have here, you can see that there's one in a running state. So let's go in and see what's happening. So there's a few things to notice here. The first is that we get the request from the Azure Alert, and then we're going to parse that and we send an approval email. And so you can see it's in that state now of sending an approval email, and it's waiting for the operator to either approve restarting of the service or rejecting the restarting, because maybe further investigation needs to happen. So this is how you can build in an approval workflow into your automation tasks. And then you can see, based on the response that the operator does from their email, one will go and call a restart service with logic app function, or the other one, it won't do anything. It'll just send an email. So let's go look and see how this restart service with logic app function is written. And you can see here it's called by the logic app. So now I'm going to go into my functions. And if you remember, I had this other one, restart service API. So this one is going to call my restart service with logic app. And so again, I'm passing in all this information about the alert from my logic app into the Azure function so I can process it. But there's a few things that I'm also doing in here. One is, because this machine is not exposed as an Azure resource, I have to be able to get inside of the virtual machine to be able to restart the service. So I'm actually leveraging our hybrid capabilities inside of Azure Functions to connect to that machine. And what this allows me to do is to get inside of the virtual machine to restart the service, but also if that machine was on premises, I could reach back into my on-premises virtual machines and restart the service inside of those machines as well. So it kind of shows the hybrid capability Azure Functions has to reach into not just Azure resources, but also back into your on-premises resources as well. And you can see it's using standard PowerShell remoting commands like invoke command. And I'm remoting onto that hybrid machine. I'm passing my credentials, and I'm going to restart the service. So how this is done in Azure Functions, if I go back to the Function app, you can see there's a networking section. And here I've configured my hybrid connection to go back into that on-premises virtual machine to be able to restart the service. But obviously, if I had a VNet set up inside of my Azure environment that reached back into my on-premises location, I could just connect with VNet integration and be able to access that machine directly as well. And so it gives you lots of options inside of Function apps in order to be able to reach into your on-premises environments as well as your lockdown Azure environment, leveraging either hybrid connections or VNet integration. And so with that, it gives you kind of an end-to-end experience where you can do an approval process inside of Logic Apps, and then based on the approval or rejection, you can call an Azure function to go fulfill that request. And so that's kind of an end-to-end scenario that lights up all the different capabilities we have inside of Azure Functions for event-based automation. So the last slide I have is talking about some new capabilities that we're releasing into Azure Functions to make it easier for you to automate your end-to-end processes. So one of the things you will see soon inside the portal is support for PowerShell 7. And so all of the great capabilities that were added to PowerShell 7, like for each minus parallel, will now be available inside of Azure Functions. The other capability we're adding is durable functions for PowerShell and Python. So if you do all your scripting in Python, all the scenarios I showed here can be done with Python as well. And this allows you to do some long-running tasks using Azure Functions. And so oftentimes you might want to be able to perform actions in steps. And so durable functions gives you that core capability now for PowerShell and Python. And then the last thing I wanted to mention was if you want to manage all of your function apps using PowerShell, there is a new PowerShell module that's going to be available soon that allow you to do all of your management of your function apps using PowerShell, the creation, setting the plans, deletion, all those core capabilities. And so with that, I'd like to thank you for going through all the different scenarios and patterns we have inside of automation, and particularly looking at event-based automation with functions. So hopefully you learned something, and please try it out. We'd love to get your feedback and make sure that we fill all your needs inside your organization. Thanks for watching.